1, 2b kind of takes what we did yesterday, the points, the lines, the planes, and it applies some theorems or some postulates to them, okay? A postulate, it sounds scary. It's just an accepted statement of fact. We just say, we know this to be true. We don't have to prove it. Do you guys know something that you're going to really love? You don't have to do proofs in this geometry class. You maybe don't know that that's a beautiful thing, but if you talk to, see, you could talk to this guy. Proofs are awful. We don't do proofs in here. So we don't have to prove that this is true. We are going to accept it as truth because somebody else has already proved it to be true, and we just get to use it, okay? So a postulate is an accepted statement of fact. So the first postulate that we're going to talk about is through any blank points, there's exactly one line. Two. Why do you think that? Through any 2 points, there's exactly one line. Why do you suppose? Right, so if I have 2, I can put any line through it, right? If I have a point here and here, I can put that line through it. If I have a point here and here, I can put that line through it. So you're brilliantly correct. Through any 2 points, there is exactly one line. Okay, here's a picture to represent it. If I have a point here and I have a point here, the only line that can go through that right now is this one. Ooh, pretend it's straight. You guys can use your notability straightness. I can't. Okay, I can do the same thing over here. If I put a point here and I put a point here, there is exactly one line, if I could draw a straight line, that goes through that. Okay, so through any 2 points, there's exactly one line. Ouch. Scratched my face. The word intersection, what does it make you think of when you hear intersection? Forward?
No, like 4.
4. Okay. Why 4?
Because there's like 4 different ways to go, I guess.
Right. Where are you when you're in an intersection?
On the street.
On the street, in a car, right? So an intersection, right, is like when we're driving, you could drive this way through or you could drive this way through, right? There's an intersection at Dumont and Artesia over there. That one only has 3, but most of them have 4, okay? That also applies with geometry. An intersection is where this line or this ray or this segment meets this line or this ray or this segment. So it's just the meeting up of 2 things. We would say, like if I have a line here and a line here, their intersection is that point where they meet, okay? So when I ask you what is the intersection of something, oftentimes it's a point, sometimes it's a line, sometimes it's a plane. It depends what's intersecting, okay? And I'll show you that in just a minute. Okay, so second postulate we're going to talk about, it says if 2 distinct lines, so 2 separate lines intersect, they intersect in exactly blank points. Look at the picture. 1, right? If 2 different lines are going to meet up, there is 1 point where they meet. Okay? So if I were to draw you a picture of that, let's say you have A, B, C, D, and E. Okay? Can you tell me the point of intersection? E is your point of intersection, right? So here's how we would write this. Here's how the geometry goes down on paper. We would say E is, actually, let's not do it that way. That's more words. We're going to switch it around. We're going to say line AC. Remember, when you name a line, you name it with 2 letters. So I'm going to call it line AC. I could also call it line AE, right? Or line EC. I'm going to call it AC. So line AC and line BD, again, I could call that BE or ED, intersect at point E. Okay, so E is the point of intersection for that setup. All right. Tell me what you know about a plane. What did we say yesterday? Was that yesterday? That was yesterday. What do we say about planes? What's unique about a plane? You remember? I said I use my floor as my example, but it's not a great example because it doesn't keep going, okay? A plane keeps going in every direction forever and ever and ever, okay? So this next postulate says if two distinct planes intersect, okay? So if my floor kept going forever and ever and ever, but then also my wall right here kept going forever and ever and ever, okay? So if my wall meets my floor, where are they meeting? What does that mean? What's the end? Are they meeting at one point? Like, where does my floor meet my wall? Is it just this one point right here? No. No. Where else does it meet? All the way across. Okay? Now think about that. A bunch of points all the way across when the floor keeps going and the wall keeps going makes what figure that we talked about yesterday? What was a bunch of points all as close as we can put them next to each other that just keeps going and going and going? What did I do this for yesterday? Not a point. Not a ray, because it doesn't have an end, right? If it had an end, which is why it's tricky using my wall, because my wall has an end, my floor has an end. You got to think planes just keep going. What thing kept going? Not the segment. The segment had the end, right? What kept going? A line, right? So here's the deal. If I have these two planes that meet up, their intersection is exactly one line. And you can kind of see it in this picture here. It's tricky because you can't draw a plane to keep going, right? But essentially the blue would keep coming this way and it would keep going that way. And the yellow would keep going that way and this way. So you kind of have to visualize something that's not able to be visualized on paper, right? But if you take a plane and another plane and they meet up, their intersection, so like if I was going to use this wall and my floor, the intersection is this whole line right here, right? All the way as far as it'll go that way, all the way as far as it'll go that way, just keeps going, okay? So when two planes meet, they intersect in a line. Any questions on those postulates? Okay, we're going to see if we can apply a few of them. So this first one, it says name the intersection of plane ADC and plane BFG. Now, when you see a question like that, it maybe looks a little confusing because there's a lot of words, a lot of planes, a lot of letters. It's just unique. So stop and ask yourself the question, what is an intersection of planes? Where do planes intersect? Where does my wall meet my floor? What do we say up here? Their intersection is a line, okay? So when you read this question, I want you to say that to yourself. The intersection of this plane and this plane, my answer should be a line, okay? So you can start off right off the bat with that. I know my answer is gonna be a line. I just need to figure out what letters need to go under there, okay? Now here's what I would do. Yeah, Isaiah.
Oh, I thought you were like, I was going to answer it.
Oh, give it to me.
Is it B and C?
Say it again.
B and C?
BC. Yeah, it's line BC. Good job. Here's what I would do if I were you, okay? I love color. I love highlighting. I love it all. I would start by figuring out what is plane, I keep changing colors. Okay, we're going orange here. Plane ADC. Now look at where A, D, and C are. Here's A, here's D, here's C. If you had to call that the front, the back, the top, the bottom, the left, the right of that figure, what would you call it? The top, okay? They didn't give us a fourth point, but if they did, it would have been this B. So that plane ADC is this. Does that make sense? Do you see that plane? What is it doing?
It's gonna collapse.
This room makes a lot of weird noises, guys. My other room didn't make those noises. Okay, so that's the first one. Now look at the second plane. We're going to do this one in that like bluish color that I've been using. Where is plane BFG? Top, bottom, left, right, front, back. It's the right side. Here's B, here's F, here's G, okay? That's right here. Now, Isaiah being brilliant spoiled our answer for us, but do you see it? Yeah? Where those two meet up, where the orange meets the blue, is right here. Okay, so our answer is line BC. And you might say, but that's not a line, that's a segment, because it has an end. But remember, planes go on forever. So if the plane keeps going, its intersection keeps going. So we make it a line because of that, even though it looks like a segment. Okay? Okay. You don't have to write this down, but I want you to try one more. So I'm going to erase all my shading here. Am I safe to do that right now? Are you done writing? Okay. So I'm going to erase this, and I want to see if you can tell your neighbor what the intersection of plane EFG and plane DCG would be. Okay, look at that picture. Plane EFG and plane DCG. Don't tell me, and don't say it loudly. Tell your neighbor quietly what you think it is. Okay? Take a look. See what you think.
How did you?
No, because they're next to each other.
Yeah, what?
She just goes like,
Look at, so EFG would be this plane right here, and then
So
this one would be right
EFG.
here. So this one back wall.
You know which plane that is?
And then that makes sense.
The bottom.
Yeah. Look, kids, right? Look, so this is this plane right here. Is this back one right there, and then the bottom one. So it intersects at that one.
oh, okay.
Back, right? DCG would be that whole back square. So we're saying, where does the bottom go back?
What? What's on the ceiling? I actually like this kind of map. That's what I'm saying. It was probably like water.
Are they gonna let you guys wear your uniform?
What'd you get?
If we don't win a game, I'm so excited. We can't win mine.
What'd you get?
Oh, HG.
HG, yes. Okay, so EFG, right? EFG is this plane, the bottom. DCG is the back one. So you're saying, where does the bottom meet the back? Any planes will intersect as a line. So your intersection there is HG. Good? Okay. Now, using that same picture, they're going to ask it the opposite way. They're going to give you the line, and you have to name the planes. So now it's two planes that intersect in EF. There we go. So EF is here. Can you tell me one plane that has EF, Isaiah?
Wait. Oh, GHE.
GHE, okay, so plane GHE is here, right? So that's the bottom one.
ABF.
ABF, the front one. ABF. Are those the only ways that you could name those planes?
No.
The answer is no, right? You could use all four letters, ABFE, EHGF. You could totally do that. True, what was your question?
I was actually gonna ask about that. Cause
It's like I read your mind, huh? No, I love it. ask away. Questions are great. Are we good there? Okay. I'm going to give you one to tell your neighbor on. Tell your neighbor rather, what planes intersect at DH? Which two planes? So DH is your intersection. Which two planes are meeting at DH? Do you guys know what the dotted lines mean? The dotted lines are like the hidden ones, the ones that are back behind.
Oh, I guess.
Okay.
Wait, what? No, that was
I know, it's trippy. You can like train your brain to see it different ways, but the back ones, do I have that one up anymore? I don't. I used to have a picture of that had.
H. Oh, with the line? Yeah.
The back. The front.
Mm-hmm. It's trippy.
That's so weird.
Okay, so what'd you get? Plane
AEH and DCG.
AEH. Okay, that's this one, is the left side. And then what was the other one?
DCG.
DCG is the back face, or you maybe see it as the front face, depending on how your eyes are adjusting. Yeah, that's where they meet. Okay? And if you want to use 4 letters, use 4 letters. That's totally fine. Okay, last thing. This is my favorite one. Through any blank, non-collinear. What does non-collinear mean?
Not a straight line.
What'd you say?
The 3 points aren't in like
They're
a straight line.
not in a straight line. So non-collinear. Through any 3 non-collinear points, there is exactly one plane. How many points do you think you need to make exactly one plane? 3. Okay. Through any 3 non-collinear points, there's exactly one plane. Have you ever sat on a 4-legged stool? I think in the science labs, there's 4-legged stools. Do they ever wobble?
Yes.
Yeah,
really
so annoying, right? Think of a cameraman. Think of a photographer.
Like a
Tripod, right?
Photography?
Why do you suppose, for photography, they use a tripod and not a quad pod, not 4-legged?
Because the triangle's like the most sturdiest shape.
Stable shape there is, yes. Through any 3 points, so my fingertips, right? 1, 2, 3. There is one plane that I can put through those. Notice my fingers are not the same length, right? But if I lay my hand down, I can keep my fingers straight and I can make every one of my fingertips touch the table without bending anything, okay? That is because through any 3 points, there is one plane, exactly one plane. I don't know why they don't make 3-legged stools more often. Maybe it just, I don't know. They should.
Like, what's gonna hold it?
Because 4 is more of a chance to wobble.
Yeah, 4 will wobble, much easier.
But what's gonna hold it?
But-
It's like,
I mean, you could do 3.
Well, yeah, like
Just think of
this,
like, you
that.
take like a
oh, the
tripod.
top's just like flat.
Yeah, the top is flat and then it stems down from each, but I guess
Yeah.
maybe that's
it's
why,
still-
because
yeah.
you have like a center point more and that's not as good as having 4 points here. But
Yeah,
through any 3 points, right? There's exactly one plane. Okay, so that means if I give you 3 points, you should be able to shade a plane for me. Okay, so we're gonna do this in 3 different colors on the same figure. If you don't like that and you wanna make copies right now, maybe you should do that. Maybe let's make copies. If you just make, oh, that's not what I want. Make a quick copy twice. That might be better in terms of not having so much overlap. I think, yeah, you know what? I'm just going to do 2 different images because 2 of them don't even impact each other. It's the third one that is a little funky. No, it's the second one that's a little funky. Okay, so I'm just gonna do 2. You can do it on 3. You can do them all in the same one if you want, but I'm gonna shade, okay? So this first one in orange, it says what plane contains the points N, P, and Q. So if you look here, here's N, here's P, here's Q. Which plane goes through those 3? Top, bottom, left, right, front, back. Bottom, right? The fourth point you could associate with it would be that R, and it is your bottom plane. Okay, so N, P, and Q would be this plane. Okay, J, M, and Q. For this one, I'm going to move down to the bottom. What does it do, Cole?
It goes from the top, which is J, M, and then down to PQ.
Yeah. So here's J, here's M, here's Q. If you think about what other point could kind of go with those, that's point P, right? It kind of cuts diagonally through. It's like taking a Kleenex box and saying, how could I connect these top 2 points with this bottom point here? Well, the only way to get through all 3 of those would be to cut through diagonally, right? So that's what you're working with there. So JMPQ, you have to cut this way. So if you just connect all those points, you get this rectangle that's on a slant.
That's
So cool, right?
so exciting.
I know. Do you love geometry?
Geometry's fun, man.
Geometry is fun. Okay, last one. I'm going to do this one in my little maroon type color. So M, L, and Q, and I'm going to go back up to that first box that we had. What face would M, L, and Q be? Top, bottom, left, right, front, back, the back. Notice the dotted lines, right? That means it's in back. M, L, Q. That fourth letter that would go with it would be what?
N?
Not the N, the R. Yeah, it would be point R. So you would get this as your figure. Okay. Make sense? Okay. That is 1-2B.